Hi and welcome. I'm trying to learn space science today series, and after we've done that, we're gonna do squat training. And if you're participating with squat training, then it's at your own risk. Now, we had series in the previous part of, I think, planetary science or space science, and now we wanna focus on Ceres. Given the fiery birth of the solar system, it would be surprising if there were no remaining debris from that stormy period. Indeed, nearly 5 billion years later, the solar system is stuffed with leftover chunks of rock, metal, and other materials. These primordial fragments of a solar nebula are known as asteroids. Asteroids have been known since 1801, when Ceres was discovered. That's for us. Ceres was discovered in 1801, and it was the first asteroid to be discovered. Since then, astronomers have found more than 300,000 of them. Maybe we're going to add that as information, but we don't really need it. And like Ceres, most orbit the Sun between Mars and Jupiter, forming a donut-shaped cosmic junk pile called the asteroid belt. Okay, Ceres is inside of the asteroid belt between Mars and Jupiter. And there are 300,000 other asteroids already discovered in this asteroid belt. There are probably way more. Ceres is by far the largest. So Ceres is the largest one, asteroid found. It has 950 kilometers as a diameter across, and the only asteroid large enough for its gravity to pull it into a sphere. Now I don't understand, does Ceres have an atmosphere, the sphere itself? We're just not gonna admit. Or we're using it as a quote, pull it into a sphere. We're saying the exact same words. Maybe we should add it, because it's the only asteroid which can do that. So it's quite important. It's the only asteroid with a gravity strong enough to pull it into a sphere. We have no idea what it means if we say it. Maybe. There are only 3 other ones larger than 500 kilometers, and it's quite the only asteroid with that size. There are only 3 other ones with a diameter of more than 500 kilometers. All of these are irregular shaped, like giant potatoes, these asteroids. Astronomers estimate that there could be as many as 25 million asteroids larger than 100 in diameter, fewer than 0.5% of which are larger than 1 kilometer. Okay, 300,000 discovered, but there are probably around 25 million. 25 million larger than 100 meter. How big would it be all them together? Fewer than 0.5% of which are larger than 100 kilometer. $25 million, 0.5%, 1% would be 250,000. So 100,000 have more than 1 kilometer. That's gonna say it. $125,000. We're gonna say 100,000, 0.5%. Okay, but maybe we should make it directly another bit to the estimate bit. Okay, what do we say about Ceres? Ceres discovered 1801, the first asteroid to be discovered. It was in 1801. Since then, more than 300,000 were discovered, and it is estimated that there are 25 million who are larger than 100 meters in this asteroid belt, where also Ceres is between Mars and Jupiter. Ceres is 950 kilometers. It's 950 kilometers across. Okay, I have a camera, and I'm going to start now. This is look how it works, and when I'm restructured again in a second. Ceres. Ceres is the first asteroid which was found. It was in 1801. and it is an asteroid which is in the asteroid belt between Mars and Jupiter. And there are around estimated 25 million asteroids, but Ceres is the biggest one with a diameter of 950 kilometers. There are only 3 other ones with a similar size. There are 4 in total over 500 kilometers in diameter, and 25 million, that is the number estimated for 100 meter asteroids. The number is 125,5% of the total number of the ones over 100 meter, which have more than 1 kilometer as a diameter. And that is according to Mark A. Garlick's Cosmic Menagerie book, page 21. There was quite a lot of information to the asteroid belt and not to Ceres. And they didn't say it on it. But maybe it's interesting. I said almost all about the thing with the Uranus roll. But it makes sense with the film. So I think we're going to take it and we're going to observe if it is okay. We have quite a little information to Ceres, and we added more information to it. If it still makes sense in the video. I'm going to stop and start the second camera. Now the question is, do we want to be asteroid belt? I think we should. The asteroid belt is between Mars and Jupiter, a donut-shaped. It's just an orbit, whatever a donut shape means. And there are 25 million asteroids which are larger than 100 meter, and 100,000 of them are larger than 1 kilometer, and 4 of them are larger than 500 kilometers, and the biggest one, 950, is Ceres, for 1801. And they are basically leftover chunk of a solar system when it was forming. Asteroids come in various classes depending on composition, but in general they are either carbon-rich, stony, or metallic. They're most of the times carbon-rich, stony, or metallic, and they're more or less leftover chunk from the forming of a solar system, which has not formed to planets as most of the other stuff in the solar nebula. Let's try it. 300,000 discovered, 25 million, 125,000, 100 million. Okay. The asteroid belt. The asteroid belt is between Mars and Jupiter, so there is Mercury, Venus, Earth, and then Mars and Jupiter. Then Uranus, Neptune, let's think for a moment. Mars and Jupiter, Saturn, Uranus and Neptune. The asteroid belt. The asteroid belt is between Mars and Jupiter. So it's the Sun, then it's Mercury, Venus, Earth, and then Mars and Jupiter, they are between, and then there come also Saturn, Uranus and Neptune. So between Mars and Jupiter there's the asteroid belt. And these are a bunch of asteroids just around the Sun, they are just there. And now there are 25 million which are bigger than 100 meter, and 125,000 which are larger than 1 kilometer, and 4 of them are larger than 500 kilometers. And the biggest one of them, discovered in 1801, the first asteroid discovered, is Ceres. That one is 950 kilometers in its diameter. And that is, and they are mostly out of carbon stuff or metallic or stone material. They are basically leftover chunk from when the solar system was formed, which has not formed into planets as the other parts. And that is according to Mark A. Garlick's Cosmic Menagerie book, page 21. I think I'm going to take that as well, like that. I'm going to stop the camera and start it again. Because I want to say one other thing at least. I had something else. I don't know what it was. When are we going to do at least the other thing? I think it was just. Okay, I want to say which of these 8 planets are the gas giants, which the ice giants, and which 4 the terrestrial. The 8 planets. The 4 terrestrial are Mercury, Venus, Earth, and Mars. And then there are 2 gas giants, Jupiter and Saturn, and 2 ice giants, Uranus and Neptune, and so on. As according to several pages, I'm going to take that one here. What is the title? How to start? What's the introduction sentence? This is start again. There are 8 planets in the solar system, and the 4 terrestrial ones are the first 4. There is Mercury, Venus, Earth, and Mars. They are terrestrial. And then there are the 2 gas giants, Jupiter and Saturn, and the 2 ice giants, Uranus and Neptune. And that is according to several pages of Mark A. Garlick's Cosmic Menagerie book, for example, page 18. Should I have added what of materials there? In a way that leads a bit too far. This is got information quite short, 8. We have it. People who do not know that will be confused with the additional information, which one are gas, icy, rocky, metallic, or whatever. I think it's okay. We're going to take it like that. I'm going to stop now the camera. And that was the space science part. If you were here for space science, you can go directly to the next part of space science. We will do now a squat training. If you participate in a squat training, then it's better to get on this. One leg up and point the foot down. And foot up and down. Down, and the other leg up. Point the foot, bring the foot up and down. Now a drain stop. Go to the side. Close the pointing forward and the inner side of the leg. And on the other side. And go from side to side. And now some squats, let's do 12. So legs wide apart and we're going down to the first one. It was the first one. And to the second one. And now to number 3 and 4. And after we've done 5 and 6, we're at half. And number 7 and 8 and on the 9. And let's make the 10 full. And last one was 2, 11 and 12. And now the 6-pack squat squeeze. Legs wide apart. We're going down into quarter squat. And press at the top against the leg. On one side of me. And on the other side. Down into half squat. And press in the middle of the leg. And on the other side. Down into 3/4 squat. And press close to the knee. And on the other side. And up again. And now the fast jab of a water pond. Down into 3/4 squat. Press against the leg. Go towards it on the other side. Press against the knee. And go towards it again. Press against it. And go towards it again. And again. And again. And last 2. And up. And now. Already the last exercise, the propeller. Down into full squat. Arms out to the side. Out to one side. Press against the leg. Look up to it. Head, little bend in the elbow. And over to the other side. Press against the leg. Look up to it. Head. And up. And walker. One leg up. Point the foot down. The mushroom, other leg up, point the foot down, and now the crane. Take the foot at the ankle, make a straight back, and point the knee down to the ground. Other leg, take it to the ankle, make a straight back, point the knee down to the ground. And legs wide apart, breathing around. And breathe again out. Again in. And out. Last one, breathing. Out. Breathing close the legs. And breathing out. That was the squat training. I thank you very much and until next time.